My dear friends, I am Sella Kumaraswamy from Coimbatore. This is a project that is a design of tall buildings using E-Tabs design software. Now, the E-Tabs is in open. Go to new model. Use built-in settings with display units as metric SI units and steel section database Indian, a steel design code IS 800 2007 and concrete design code IS 456 2000. Click on OK. Now the grid dimensions, uniform grid spacing, I am go to custom grid spacing. In which edit grid data. Now here the values for editing, use display grid data as spacing. Here I am fixing a spacing of 6 meters and 4 meters and again 6 meters. Similarly, in Y grid data I am fixing as 5 meters in 1, in 2, 4 meters and in 3 again 5 meters. Click on OK. Now use grid only option and click on. Now I am going to simple story data. Here number of stories in this project is say 14 and typical story height 3 meter and bottom story height also 3 meter. Now in custom story data, if we want to edit any data in the stories, we can do here, but I like to left as it is. Click on OK. Now the grid is formed as per our input and we have to define material properties first. We need to define required materials. In this dialog box, a region is India and material type, the first one is concrete, the standard Indian standard, and here I am using M40 concrete. Okay. And all the default values are agreeable, hence click on OK. M40 is defined and now add a new material, that is rebar. As per Indian standard HYST, I am proposing HYST grade 550 for longitudinal bars. Let's click on OK. And again I want to add new material, same rebar, that is mild grade 250 for confinement reinforcement. Click on OK. Again we need masonry. Click on OK. Again click on OK. Now we have defined M40 concrete, HYSD 550 steel grade and mild 250 steel grade and masonry. Now let us go to define section properties, in which frame sections add new property, that is column rectangular, name it as C 500 by 350, that is column having a size of 500 by 350 mm. The material is M40 and here the depth is 500 and width is 350 mm. And reinforcement, go to modify show rebar. Here our element is column, is longitudinal bar HYSD 550 steel grade and confinement bars mild 250. Then clear cover for confinement bars 40 mm, that is okay. So click on OK. Again click on OK for reverse. Now we have defined one column section and I want to add copy of property of defined column section, say C 600 by 450 mm, that is column 600 mm by 450 mm. The material is M40 and the depth is 600 and width is 450 mm. So rebar the same M2 M3 design and longitudinal bars HYSD 550 and confinement bars mild 250 and cover is 40 mm. Let as it is. Click on OK. Again OK for reversal. Again I want to add a copy of one more property. Here C 750 mm by 450 mm. Here the depth is 750 mm and width is 450 mm and rebar everything is same. Let's click on OK. Here it is a mistake, 750 only. Okay. Click on OK for reversal. Now we have defined three sections for column. Now add new property. Here choose auto select list name it as C auto select here. Auto select design type as concrete and choose all three columns and add in the auto select list and click on OK. Similarly, we are going to define beam sections. Let's go to add new property, concrete rectangular beam section, name it as B 500 by 350 mm, material M40 grade concrete and depth 500, which is 350 mm, and modify show rebar. Here go to M3 design only and longitudinal bars HYSD 550 steel grade and confinement bars mild 250 steel grade. Here the longitudinal rebar loop centroid cover to the top bars 25 mm is enough. In the bottom also 25 is enough. Hence click on OK. Now click on OK for reversal and add new property. Here B 600 by 450 mm, material M40 and here dimension depth is 600 and width is 450 mm. Modify so rebar M3 design only HYSD 550 and mild 250 25 mm cover in top 25 mm cover in bottom. Let's click on OK and again click on OK for reversal. Again add a copy of property. Here B 750 by 450 and M40 concrete 75 40 modify show rebar, or all things are okay and click on OK for reversal. Now we have defined three beam sections and go to auto select property, add new property, that is auto select list. Here B auto select auto select design type is concrete. Now choose all three beam sections and add in the auto select list. Click on OK. Now we have defined three beam sections and three column sections. Click on OK. Again go to define again section properties, that is slab sections. Add new property, say slab 150, slab materials M40 grade concrete, and slab thickness is 150 mm. 150 mm and click on OK. The slab is defined, and let us go to define wall section. In section properties, wall sections, here add new property, it is shear wall. Shear wall. Here the wall material is M40 grade concrete and the thickness is say 300 mm. Click on OK. Shear wall is defined. Let's go to define brick wall. Brick wall. Wall material is masonry and the thickness of the wall is 230 mm. Click on OK. Now we have defined a brick wall and shear wall. Brick wall with brick masonry and shear wall with M40 concrete grade. With this we have defined all the section properties. Required for the design of this tall building. The next part is drawing beam columns, shear walls and slabs. Go to draw menu. Here draw. First we have to draw shear wall. Before that, switch to all story option in 3D. Go to draw wall objects, quick draw wall plans. Here change the property. Shear wall. Now go to select shear wall part in the grid. This part is our shear wall. The shear wall is drawn. Next, we have to draw columns. So go to draw beam column face objects in which quick draw columns. Here change the property to our column auto select. Now choose the column in the grid. These are our columns in this building. Now all the columns are selected and drawn. Now go to draw beams. Draw beam column base objects in which quick draw beam columns, beam/columns. Here change the property to beam auto select. Now select the beams. Now all the beams are drawn in all stories. And let us go to draw slabs. Draw floor or objects in which draw floor walls. Here change the property to slab 150 and now select the slabs. Accept the shear wall part. Now the slabs are drawn in all 14 floors. Now drawing the brick wall is the technique. Go to draw wall, floor, /wall objects in which draw walls. We draw walls. Here change the property to brick wall. Brick wall. Now let us select the brick wall parts, that is outer beams. Outer beam portions ஒரு அரை மணி நேரம் வச்சு போட்டு கொஞ்ச நேரம் வச்சு போட்டு Now the outer walls are drawn to the 14 stories. Now all the elements are drawn. Now assigning the joints at base. Go to our third part is, second part is over and let us go to third part. Here the plan view is at story 14. Now go to base. this is our base. Here switch to one story option and select joints. Here the 16 joints selected. Now before that we have to delete the shells, the 8 cells, 32 edges. There is no slabs in this story, so escape. Now this select slabs, delete them. Now select the whole area. So only 6 joints are selected now. Now go to assign joints in which restraints. Here choose these restraints in all directions. Then apply and click on OK. Now the joints are assigned to the rigid connections. Now let us go to assign loads. Here move this plan view to upper story. For assigning the shell loads and frame loads. Now switch this to all stories option. Here select all the cells one by one. Now all the cells are selected and go to assign shell loads in which uniform and dead load is okay. First we have to assign the dead load of uniform load of 2 kilonewton per square meter. The direction is gravity and apply. A dead load of UDL is applied on all the slabs. Now go to assign live load. In similar manner, go to shell load, uniform. Here the load pattern is live load and I am going to apply a load intensity of 5 kilonewton per square meter as gravity and apply in all stories. Here we have to select slabs before assigning the loads. Okay. Select all slabs. And now go to assign shell loads, uniform, live load 5 kilonewton, gravity, apply. Okay. And in the top story we need not apply 5 kilonewton live load, hence it has to be removed. So go to the top story, that is story 14. Here, go to switch to one story option and select the cells. Each cells are selected in the top story and go to assign shallow, uniform, live low. Here 2 kilonewton is enough because it is a top story. Apply 2 kilonewton. Replace the existing load. Okay. Now the dead loads and live loads are assigned there. Let us go to assign wind loads. Here go to define the load pattern and introduce wind load. Wind type is wind and here IS 875 1987 and add new load and modify lateral load. Here the wind speed is 35 kilometer per second, terrain category 2, structure class B, and this coefficient 1 and topography factor is also 1, and wind direction and exposure width. Here wind coefficient say 0.7. Click on OK. And leeward coefficient is 2.2. Click on OK and click on OK for reversal. Now let us go to assign wind load, for which we go to elevation. Here A, apply A, click OK. This is elevation for application of wind load. Select all the cells . Assign shallows. Here wind pressure coefficient, wind coefficient 0.7, windward side, apply. Again go to plan view. Okay. Come to elevation. One. Apply. Okay. Here select cells. Go to assign, shallows, wind pressure coefficient, apply. Okay. Go to plan view. Okay. Apply. Here windward sides are assigned. Now go to wind leeward side, that is apply D. Click on OK. Go to assign, shallow, wind pressure coefficient. Here minus 0.2. This is leeward side. Apply and click on OK. Again elevation, go to 4. Apply, click on OK. Here select all the shells. Go to assign, shallow, wind pressure coefficient on leeward side. Apply. OK. Now Go to plan view. All sides wind force is applied. Now go to assign, go to the next part, analysis. Go to analyze, run analyze. Here save the file as tall building design. Save. Now the analysis by the software is over. We can see the force stress diagrams. Expand. Check the shear force. And moment. Now the analysis is over. Now let us go to design. Concrete frame design. You revise reference. Here the design code is IS 456 2000. Hence click on go. Again go to design, in which concrete frame design, start design / check. Now the design process is carrying out by the software. Analysis and design section refers for 448 concrete frames. It asking as do we want to rewrite analysis and design? Yes, permit it. Here by using auto select option, the software will choose the best section for suitable best section according to the external loading. Now the design is over. All values are displayed. You can see the longitudinal reinforcement area of the longitudinal reinforcement at any point by moving the cursor. Now go to design menu, again concrete frame design. We can verify whether all the members are passed. All concrete frames passed the design check, hence the design is safe. Now the design is over, we can create reports. Go to reports, here double click on project report. The software generates the project report and as well as summary. The report is generated by the software including table of contents and the list of tables, all required values. The report contains the pages, number of pages 473. This is project report. Now click on summary report to obtain the summary. This is summary report generated by the software. It contains 23 pages. With this, our design project is over. Thank you, one and all.